before there was land to stand on, before there was water to drink, before the sky even knew what blue was, Earth survived something no planet should. Imagine this for a moment. You are floating in space, watching a newborn world being beaten, burned, shattered, and rebuilt again and again. Not over centuries, not over millions of years, but during the most violent opening chapter of its entire existence. This is not the peaceful Earth we know. This is Earth's survival story. Hey, everyone, welcome back to Earth's Archive, the place where we don't just talk about planets, we uncover their memories. And today, we're traveling back further than any human mind can truly imagine, to the first 100 million years of Earth, a time when our planet was closer to hell than home. Stay with me, because by the end of this journey, you'll realize something shocking. The Earth didn't slowly become habitable. It fought for it. When Earth first formed, it wasn't a planet the way we understand planets today. It was more like a glowing wound in space, a chaotic ball of molten rock, metal, and fire, born from the violent leftovers of the sun's formation. Everything was unstable. Nothing was settled. Gravity was still gathering Earth's body piece by piece. Asteroids the size of mountains slammed into the surface non-stop. Each impact didn't just leave a crater, it reshaped the planet entirely. The ground never cooled long enough to become solid. The surface cracked, melted, and reformed endlessly. If you could stand there, which you couldn't, the heat alone would tear you apart instantly. And yet, this destruction was necessary. Every impact added mass. Every collision added material. Earth was growing, learning how to be a planet through pain. Heavy elements like iron sank inward, pulled by gravity, forming Earth's core. Lighter materials rose upward, slowly building the early mantle. This separation created something powerful: heat, pressure, and movement, the early engine of Earth itself. But the violence didn't stop. Space was crowded. The early solar system was a shooting gallery, and Earth was a target. One impact, though, changed everything. A Mars-sized body, we call it Theia, slammed into Earth with unimaginable force. Not a gentle collision, a planetary-scale catastrophe. Earth's crust vaporized. Rock turned into plasma. Debris was launched into orbit, glowing like a ring of fire around the planet. From that destruction, the Moon was born. Yes, Earth's greatest companion came from its greatest wound, and from that moment on, nothing was the same. The Moon stabilized Earth's spin. It controlled tides that didn't yet exist. It helped shape the rhythm of days and nights long before life ever appeared. Without that collision, Earth might have spun wildly, tilting unpredictably, never becoming stable enough to support life. This is where Part 1 slowly comes to a close, with Earth scarred, glowing, and newly accompanied by its silent guardian in the sky. And now, things get even more intense. As we move into Part 2, Earth enters a phase that scientists call the magma ocean stage. But don't let the name fool you. This wasn't calm or beautiful. The entire surface of the planet was molten. No continents, no oceans, no atmosphere you could breathe. Just fire. Volcanoes weren't rare, they were everywhere. Lava oceans stretched from horizon to horizon. The sky was thick with toxic gases, carbon dioxide, methane, sulfur, released from Earth's interior. There was no oxygen, no protection, no mercy. And yet, something incredible was happening. Water was arriving. Some came from inside Earth, released through volcanic eruptions. Some came from icy asteroids crashing into the surface. At first, water couldn't stay. The heat boiled it away instantly. Steam filled the sky, trapping heat, creating pressure, thickening the atmosphere. Earth was learning how to hold on to water. Over millions of years, the surface cooled just enough. The rain began. Not gentle rain. Endless storms. The sky collapsed for thousands of years straight. Rain hammered the surface, filling low points, carving rock, creating the first oceans. Imagine standing back and watching it. A planet, screaming, under constant storms, yet slowly transforming into something new. And deep beneath those oceans, the planet's interior stayed alive. Heat flowed. Plates began to move. Earth became dynamic, alive with motion. This movement would later recycle nutrients, regulate temperature, and protect life. But at the time, it was just survival. By the end of this phase, Earth was no longer just a ball of fire. It had oceans. It had an atmosphere. It had cycles. And now, Part 3 begins, the most important transition of all. Earth enters the final stretch of its first 100 million years, and this is where possibility is born. The bombardment from space slows down. Impacts still happen, but not constantly. The surface stabilizes for longer periods. Crust thickens. The first protocontinents begin to form. Small, unstable land masses rising and sinking like rafts. The oceans are hot, dark, and acidic. No sunlight reaches deep. But chemistry is working quietly. Elements mix, energy flows, reactions repeat. Earth is no longer just surviving. It's preparing. Somewhere in these waters, possibly near volcanic vents, molecules begin organizing in ways never seen before. Not life yet, but pre-life. Systems capable of copying themselves. Structures that respond to their environment. The planet doesn't know it yet. But it's setting the stage for the greatest transformation in its history. By the end of its first 100 million years, Earth has done the impossible. It survived relentless impacts. It survived total melting. It survived atmospheric collapse and rebirth, and it emerged not perfect, but ready. When we last left Earth, it wasn't a world you could recognize. It wasn't blue. It wasn't green. It wasn't alive. It was glowing, literally glowing, like a coal pulled fresh from a furnace, floating alone in the darkness of space. Now imagine this planet from above. No continents, no oceans, no clouds drifting peacefully across the sky. The entire surface is molten. Not patches of lava, not volcanoes here and there, but a global ocean of fire. Rock behaves like water. Waves of magma rise and fall. The ground itself is liquid, constantly reshaping, constantly moving. This is Earth during its magma ocean phase, and it lasted for millions of years. The heat didn't just come from the sun, it came from within, from the energy of countless impacts, from radioactive elements decaying deep inside the planet, from gravity squeezing Earth tighter and tighter as it grew heavier. There was nowhere for the heat to escape. Above this molten surface, the sky was nothing like the sky we know today. It was thick, heavy, toxic, a suffocating blanket of gases released from Earth's interior. Carbon dioxide dominated the air along with methane, nitrogen, sulfur compounds, and water vapor. No oxygen, not a trace of it. If you could somehow stand there, which again you couldn't, the pressure alone would crush you. The air was dense, hot, and choking. The sky wasn't blue. It was dark, hazy, and violent. Lightning cracked constantly, through thick clouds of steam and ash. Earth was venting itself. Every eruption was the planet releasing pressure, slowly bleeding out the chaos of its birth. Volcanoes weren't isolated mountains. They were global wounds, tearing open the surface again and again. Lava fountains rose kilometers into the air. Rivers of molten rock flowed endlessly, reshaping the surface in hours instead of centuries. And, still, something extraordinary was happening. water was beginning to matter. At first, water had no chance. Any liquid that reached the surface instantly flashed into steam. Oceans could not exist yet. Rain fell, but it never reached the ground as rain. It evaporated before it could touch the lava below. But Earth kept receiving water anyway. Some of it came from deep inside the planet, trapped during formation and slowly released through volcanic activity. Some of it arrived from space, delivered by icy asteroids and comets crashing into the surface. Yes, even during this hellish phase, space was quietly delivering one of the most important ingredients for life. Water accumulated in the atmosphere. The sky grew thicker. The pressure increased. Heat became trapped. Earth entered an extreme greenhouse state far beyond anything we experience today. The planet wasn't cooling, but it was changing, and change is everything. Over time, millions of years, the bombardment from space began to slow. Impacts still happened, but not constantly. Earth finally had moments to breathe. The surface, still molten, began to cool ever so slightly. And when it did, something historic happened. Rain began to fall and stay. Not gentle rain. Not storms that passed in an afternoon. This was rain that lasted for centuries. Thousands of years. A sky that collapsed endlessly, pouring water onto a planet desperate to hold it. When the first true rain reached solidifying rock, it hissed violently, turning to steam. But as temperatures dropped just enough, water stopped vanishing instantly. It pooled, it flowed, it collected in low regions of the surface. The first oceans were born. They weren't blue. They weren't calm. They were dark, hot, acidic, and violent. Meteorites still crashed into them, boiling entire regions instantly. Steam explosions tore through the surface. Waves towered like walls, but they were oceans. For the first time, Earth had stable liquid water on its surface. And that changed everything. Water became a shield. It absorbed heat. It protected the surface from radiation. It allowed chemical reactions to occur over long periods of time. It carried minerals. It connected regions of the planet together. Below these early oceans, Earth remained alive. The interior was still hot and active. Heat flowed upward, driving movement in the mantle. The earliest tectonic behavior began. Not the clean plate tectonics we know today, but chaotic shifts, sinking crust, rising material, constant recycling of the surface. Earth was becoming a system. The atmosphere also began to evolve. As water condensed into oceans, water vapor decreased in the sky. Carbon dioxide began dissolving into the oceans, reacting with minerals, slowly locking itself away. The atmosphere thinned, cooled, and stabilized. Not enough for life yet, but enough for balance. Day and night became more regular. Thanks to the moon, Earth's rotation slowed and stabilized. Tides, violent and massive, churned the oceans endlessly, mixing chemicals and energy. Nothing on this planet was still. By the end of this phase, Earth was unrecognizable compared to its beginning. It was no longer a glowing fireball. It had oceans that covered most of its surface. It had a thick but evolving atmosphere. It had internal motion. A living interior that refused to go silent. Most importantly, it had time. Time for chemistry to experiment. Time for patterns to repeat. Time for complexity to quietly prepare. Earth still looked hostile, still deadly, still alien. But beneath the chaos, something subtle was emerging. Stability. And stability is the doorway to life. As we move toward the final part of this story, Earth is no longer just surviving its birth. It is preparing for its future. By the time Earth approached the end of its first 100 million years, something had fundamentally changed. The planet was no longer reacting blindly to violence. It was responding. Earlier, every impact rewrote the surface. Every eruption erased what came before. But now, Earth had begun to remember. Layers formed. Structures persisted. The surface no longer reset itself with every catastrophe. From deep space, this young Earth would finally resemble a planet rather than a burning scar. Dark oceans dominated the surface, absorbing sunlight instead of reflecting fire. Patches of solid crust rose above the water like wounded islands, unstable but real, existing long enough to influence the environment around them. This was not a gentle world, but it was a coherent one. The bombardment that once defined Earth's existence had slowed dramatically. The inner solar system was clearing. The debris left from planetary formation had either collided, been captured, or flung away. Impacts still occurred, sometimes devastating ones, but they were no longer constant. Earth finally had time between disasters. And time is the most powerful force in planetary evolution. The oceans, though hostile, were now permanent features. They boiled near volcanic regions and froze near cooler zones. They churned endlessly under massive tides raised by the moon, tides far stronger than anything we experience today. These tides didn't just move water, they mixed the planet, transporting heat, minerals, and chemical energy across vast distances. Earth was stirring itself. The water was not clean. It was thick with dissolved minerals, metals, and gases. Iron, sulfur, carbon compounds, all circulating, reacting, combining. Lightning storms cracked constantly through the dense atmosphere, injecting energy directly into the oceans below. Energy plus chemistry plus time. This combination is not random. It is inevitable. Beneath the oceans, the planet's interior continued its restless motion. Heat from radioactive decay and leftover formation energy drove convection in the mantle. Portions of crust grew denser and sank, while new material rose to replace them. This wasn't modern plate tectonics yet, but it was something close, a young, chaotic version of the process that would later shape continents. This internal motion mattered more than Earth could possibly know. It recycled materials. It prevented chemical stagnation. It kept nutrients moving between the deep interior and the surface. Without this motion, Earth would have become chemically exhausted, locked into a static state incapable of supporting complexity. The atmosphere continued its slow transformation. Carbon dioxide dissolved into the oceans and reacted with rock, locking itself away as carbonates. Water vapor condensed and fell as rain. Pressure gradually dropped. Temperatures slowly stabilized. Still no oxygen, still toxic, still deadly to anything we'd recognize as life. But Earth was no longer swinging wildly between extremes. It had entered a narrow window, a fragile balance between chaos and calm. And within that balance, something extraordinary began to take shape. In the dark depths of the oceans, especially near hydrothermal vents, conditions were unlike anywhere else on the planet. Superheated water, rich in minerals, burst upward from cracks in the crust. Temperature gradients existed side by side, scalding heat next to cooler regions. Chemical energy flowed constantly. These environments acted like natural laboratories. Molecules formed, broke apart, and reformed endlessly. Most combinations were temporary. Most structures collapsed as quickly as they appeared, but a few configurations proved more stable than others. They persisted. Some molecules formed membranes, thin boundaries separating one internal chemistry from the surrounding environment. These boundaries were not alive, but they were selective. They allowed certain substances in and kept others out. That alone was revolutionary. Other molecular systems began storing information, simple patterns that could be copied imperfectly. When copied, variations appeared. Most variations failed, but occasionally a change made the system more stable, more efficient, more likely to persist. This was not life, But it was no longer purely chemistry. Earth had crossed a threshold where matter began organizing itself against entropy, using energy to maintain structure. And the planet didn't guide this process. It didn't plan. It simply provided the conditions. The rest followed naturally. Above the oceans, the sky remained thick and ominous. Clouds of steam and gas swirled endlessly. Sunlight filtered weakly through the haze, casting a dim, copper-colored glow across the surface. The sun itself was fainter than it is today, yet Earth remained warm, held in a greenhouse embrace by its atmosphere. Meteor impacts still struck occasionally, sometimes boiling parts of the oceans, sterilizing regions entirely. But life's precursors didn't need stability everywhere. They only needed somewhere. And somewhere always survived. This is one of the most profound truths in Earth's story. Destruction did not stop progress. It filtered it. Every catastrophe eliminated fragile systems and left behind only those capable of enduring. Earth was unknowingly training life before it even existed. As the first 100 million years came to a close, Earth stood on the edge of transformation. The planet was still hostile by human standards, but it was no longer hostile to complexity itself. The rules had changed. From this point forward, Earth would never return to its original state. It could not become a molten fireball again without being completely destroyed. It had cooled too much, organized too deeply, evolved too far. The foundations were set. Oceans permanent. Atmosphere cycling. Interior active. Chemistry dynamic. This was the platform upon which life would soon emerge. Every living thing that would ever exist, bacteria, trees, dinosaurs, humans, depended on this exact sequence of events. Change any one factor slightly, and Earth might have remained sterile forever. No moon to stabilize rotation. No tectonic motion to recycle nutrients. No oceans deep enough to protect chemistry. No atmosphere thick enough to trap heat. Life is not guaranteed. Earth earned it. As this first chapter ends, Earth does not yet breathe. It does not yet see. It does not yet think. But it is no longer silent. The planet hums with potential. Every system interacting, every cycle reinforcing the next. The stage is set. And in the next chapter of Earth's archive, something happens that reshapes the planet more dramatically than any impact or eruption ever could. Life begins. If this journey through Earth's violent youth fascinated you, make sure to like this video, subscribe to Earth's Archive, and share it with anyone who loves uncovering the deep story behind our world. Because in our upcoming videos, we'll explore how Earth crosses the final boundary, from a world of chemistry to a world of biology, and how that single transition changes the fate of an entire planet. Stay tuned for upcoming videos. The archive is far from finished.